All right. Little quote to get us started from today, this from John Smith. You remember Jamestown colony got started, they were looking for gold. In fact, the first couple of winters, they had a hard time having enough food to eat just because people wouldn't plant. They were too busy out looking for gold, trying to find the get-rich-quick scheme. They finally put John Smith in charge, and he said, well, part of the problem was at the beginning of Jamestown, it was a communal approach. If you went out and caught a fish, you didn't own the fish. That wasn't your fish. That was the colony's fish. And so one of the things under John Smith, they kind of went to private property. They said, great, this is your land. Produce what you can on that land. Keep everything you produce. And that's when things really turned around for him. But even prior to that, he says this: you must obey this now for a law, that he that will not work shall not eat, except by sickness he be disabled. For the labors of 30 to 40 honest and industrious men shall not be consumed to maintain 150 idle loiterers. It's just the very reality of trying to carve out a new existence in a wilderness. Everyone has to work. So again, this idea of the nobility of work over here in America. All right, exam ran last week. Oh, what do we see? So there was a few people that got the high score of full marks, and average score down here 83-84%, which is about normal. There's some is there some laughing? What's the funny part about this? Can you break it down by what the FBA's got? So we were lower. Oh, really? I actually not without a little effort, but stand by. So yeah, so this actually, I think this actually is for the IS 520 portion of the exam. Let me see if I can figure out how to. Let me see if I can figure that out real quick. Yeah, I haven't even looked, so this will be, oh, come on, Learning Suite. All right, let's try it this way. Faculty access, exam detail. I think that was probably against FERPA. Standby. Export. There should be a summary here. Oh, exam statistics. Here we go. So this is, so yeah, okay. So high score the same for this group, low score quite a bit lower, average a little bit lower as well. Okay, so that's just the different classes. So I'm not planning to kind of go over question by question during class. How many of you would like to go over that exam question by question? A few of you. So I'll probably set up a time to do it during like Thursday at 11 or something. We'll find a room and we can get together. Yeah. Is it possible, like, are we able to get our scan from that so we can see where our gaps in knowledge? I think you can probably see it now at the testing center site. Yeah. If you do it Thursday at 11, I know it's just a potential time to record it because I know I have class during that time. Blast. No, I can't record it. So if you can't make it, you'll have to come to my office and like review it on a one-on-one basis. Yeah, because the most of those questions will get used again next semester. So no recordings. All right, let's go ahead and do the content for today. So you will remember that we left off in the fascinating, gripping problem of how are you going to get to 35, 36 different properties in the shortest amount of road time possible. And so that is, that's what we're trying to solve. So we have the road distances here between each of those 35 properties. So in other words, to get from the Sheraton Phoenix downtown hotel to the Salt Lake City Sheraton is 653 miles. So we've got between any two properties, we've got the road distance. Here's a couple that are pretty close together. This is down in Tempe, so Phoenix area. And of course, this one down is downtown Phoenix, so only 8 miles apart from each other. Our code that we left off, and we're going to pick up right where we left off before. So if you were following along, you can just pick up right where we left off. If you want to go to download that file, of course, it will be on the October 18th day at vbacourse.blogspot.com. So you'll find that day, and this is where the file is uploaded. So just as a review, we declared our 3 arrays that we're going to be using to solve this problem. We declare them at the top of the module instead of inside any subprocedure. What does that do for us? Go ahead.
Makes them universal.
Yeah, it makes them what we call module level variables. Module level variables. And of course, arrays are just a whole bunch of variables declared with one statement. And so the important part is that they can now be accessed from multiple different procedures in the module. So any procedure in that module now has access to that, to those arrays. Now, we are not saying how big to make these arrays when we declare them. And so these are not static arrays. These are dynamic arrays. And all we're really saying here is we're saying, all right, get ready, because at some point we're going to say how many variables to create, but we haven't said it yet. So when we declare without putting a number inside the parentheses, we're just saying we're going to have to actually redim it, because redim is executable code, whereas dim is not executable. Dim, all the variables get allocated before any code starts executing. But redim down here, where we actually are now going to give it the size, whoops, here we're going to give it the size. So we're starting off by saying, hey, let's get a variable called hotel count, and then let's read off the worksheet how many hotels there are. And so we did that just by coming over here to the distance sheet, and we said like start on A2 and like do a control shift down and just count how many cells that is. That's how many hotels we have. And the idea here is that if we decide to use a different part of the problem that's maybe got 25 hotels or 45 hotels, we can drop it in, drop the data in, and our code will still work on that. So that calculates the hotel count. Now, wait a minute. We're going to need a variable for every one of those hotels in our hotel array. So how come we're declaring this, or we're resizing, redimming this array to be 1 less than the count? Why 1 less than the number of hotels? That's right. Arrays by default in VBA start counting at 0. So if we want 36 hotels, we're going to declare this, or we're going to redim this to have 35. And that will give us 36, numbered 0 through 35. So it's a kind of a strange thing about VBA, is that instead of saying how many variables we want, we say what's the top index that we want. And so that's a little bit different. Now, the distance to the route hotel is just exactly the same, except it's going to be an integer instead of a string, where I'll review what we're using that array for here in just a minute. Distance array is different because we've got we give it 2 arguments when we redim it. So what does this mean? So this is a 2-dimension array, which means for every variable now that we're creating, we're going to have to supply 2 numbers to identify it. Over here, we get 0 through 35. And so we supply 1 number, 0 through 35, to talk about the variable that we're interested in that array. For our distance array, we're going to have to supply 0 through 35 as the first argument, and 0 through 35 for the second argument, to indicate which of the variables that I want. There's a lot more variables. In fact, there's 36 times as many variables in my distance hotel, or my distance array, compared to either my hotel or my route array. Show me on a scale of 0 to 5 on your hands how you're feeling about this multi-dimensional array. Seeing 5s, 4s, 5s, and 3s. Okay, so the whole point is that it's just more convenient for us. What's 36 times 36? I don't know. 36 times 36. So we're getting 1,296 variables here. And rather than trying to refer to them all with one index number from 0 to 1,295, we're saying, this will be easier if we think of this as a grid, and then we can use 2 numbers to identify each variable. Question here.
Yeah, can you just remind us why you're dipping it at the top? Because you're really not allocating the memory until you read it, correct?
Oh yeah. So the question is, I say we're dimming them up here at the top, but we're not even allocating the memory till we're down in here. And the answer is because we declare them up here at the top, it changes the scope of the variables. It means it's accessible from a different place. This variable here, hotel count, this is only available inside this subprocedure in it. It's declared inside this subprocedure. It's only accessible from inside the subprocedure. So this one, however, though, is declared outside of any of the subprocedures. It's accessible from anywhere in the module. And that's referred to as the scope of the variable. Where is it accessible from? Incidentally, suppose we wanted to have another module and we wanted code to be able to refer to these arrays from the other module as well. Well, instead of saying dim, I could say here public, PUBL. See, it actually wouldn't hurt to leave it that way, which I may just do on this particular one, but that makes it even a higher scope. It means that now if I have code in any module inside this project, then it can refer to that variable. So it's just a matter of kind of limiting where we can have our variables accessible from. And the truth is, you always want to declare your variables at the lowest scope possible to prevent you from inadvertently having code that changes value in a variable. And can you imagine if, an interesting thing, let's suppose I had another module here, insert a module. Don't do this, but just watch. And I had a public x as an integer. So, I mean, don't ever make a public variable with just a one character name for crying out loud. But if I did that, and then over here in the module where I'm working on this, let's say I forgot to declare, I just forgot to put this line in. So when I was going to declare a local variable here called x because I'm going to use it for controlling this array down here, but I forgot to declare it. But now, because over on some completely different module, I have a public variable declared, it goes, oh yeah, x, got it. Even though it says option explicit, it's going to go, yeah, you've declared that variable. And whatever I was planning on using this variable for in this other context, over here now, I'm manipulating, I'm changing the value of that global variable. And so that's why you want to always declare your variables at the lowest scope possible so you don't kind of accidentally bump into another one and use one that you'd kind of forgotten you declared or something like that, especially as your projects get big. And it only takes a couple of weeks for you to almost completely forget the code that you've written. So when you're looking at it, it's like someone else wrote it. Go ahead.
And since it's outside the subprocedure, is there actual data actual storage for like hotel route? Does it maintain even after the sub?
So yeah, that's right. So one of the interesting things is that, I know folks on the video, you didn't hear the question, but I'm going to give a whole coherent statement about what that question was. Okay. So, right, when we declare a variable inside the sub procedure here, that memory gets allocated when the sub procedure gets called. So we're going to call this sub procedure first. Step one, allocate. My snapping's almost back. Allocate the memory that we need, and then when we get to the end of the sub procedure, we go, oh, I guess we're done with that memory. We're going to release it back to the operating system to do whatever it wants to with it. We don't need it anymore. But when we declare the variable up here, as soon as our code starts running, whichever sub procedure runs first, all of the module level variables get allocated, and they keep their value, they stay allocated in memory until all the code is done running. So it could call this procedure, that procedure could call another one, could call another one, could call another one, and then it could kind of come back off the stack and go call something else. And during all those different calls, when the procedures are kind of running and completing, all of our module level variables stay allocated in memory. And then once kind of all the code is like, whew, done running VBA code, that's when they get dumped out of memory. And when I say dumped out of memory, I mean just the interpreter tells the operating system, hey, thanks for this great memory, worked out well for us, and here it is. Do whatever you want with it, we're done. Other questions? Yes. Oh, can we make a public constant? Yeah, absolutely. So we haven't really talked much about constants. A constant is just a variable. Public, oh, let's see. Now you know what? I'm trying to think. I'm not sure exactly how to do it. Did you say public const? I think you do it like this. Public const, let's just do pi. as single. And then you give it its value right here. Yeah, that looks like syntactically that's valid. So, so constant is like a variable, exactly like a variable, except what? Yeah, you give it its value when you declare it, and then it can't change. So it's a location in memory with a name that has a value, but a constant you don't change. Variables you change, constants you don't change. Oh, just for kicks, let me just come over here and inside of init, let me just print pi, to be sure. Yeah, so that does execute that, and it sees that public constant just fine. We're not going to be needing the public constant. Okay, other questions? I know it's been over a whole weekend since we started this problem, so but we're going to pick it up and solve it now. Should get it finished during class. All right, so let's just kind of review. So again, over here on my arrays sheet, I'm not really using this sheet for anything except to be able to have a visual representation of what the arrays in memory look like so that we can kind of point at them and look at them. So when I allocate this first, we're going through the redimming. And so this is just actually setting up the size of those arrays. When we go through this redim process, what will be the value of all of my hotels after I redim? I've got 36 variables inside that array. And what's the value of every one of those variables right after this line executes? Now this is a string, so it's going to be the default value for string variables, which is an empty string. Yeah. Okay, so right when we redim the route hotel, or the route array, excuse me, what's going to be the value of the 36 of each of the 36 variables in the route array? Yeah, because this is a numeric type, the default value for those variables is going to be 0. And that's a problem because the route is what? The route is our way of saying these are the hotels we've been to. And 0 is one of our valid hotel numbers. Our hotels are numbered 0 through 35, and we're using the route to keep track of which hotels we've been to. So when we're going to start at hotel, let's say we're starting at the hotel in Salt Lake City, which is hotel number 1. From there, we're going to Las Vegas, hotel number 7. I think 19 is the next one we're going to, but this is how we're establishing the route. Number 1 says start in Salt Lake City. The number 7 here says go to the one in Las Vegas. And then the number 19 says go to the one in Anaheim. I'm not entirely sure that's right. That's just my recollection, but we're going to some location. But that's what we're using for the route array. And so to keep track of just the hotel numbers, the index numbers from the hotel array, that's going to say this is the order that we're going to the different properties in. So that's what it's built for. And the problem is that whenever we have to go somewhere, we have to ask ourselves the question, have we been there yet? And before we say, hey, this one's one we're going to go to, is this one that we've been to? And if we have that full of zeros, then our array is starting off by saying, we've been to whatever hotel 0 is, something in Los Angeles, the Los Angeles Downtown Hotel. And so that's why we're going to initialize this with a bunch of -1s to start off, because we don't want to inadvertently say, I think we've already been there. And that's then, and of course, we're declaring our distance array to be a 2-dimensional array to hold this whole set of numbers here as well. Then we're initializing the hotel array. We're just saying, listen, we're going to take a variable from X to the upper boundary of the hotel. So as this loop runs, the first time through X will equal 0, the second time through 1, the next time through 2. And so it's going to say hotel 0 equals, look at the distance sheet, look at cell row 0 plus 2, so row 2, column 1. So we're looking at the distance sheet, row 2, column 1. And we're going to read this string variable and put it into the hotel sub-0 variable. The next time through the loop, we'll be writing to number, X is going to change to 1. This will be a 1. That will be a 1. So we'll be looking at row 3, reading column 1, and we're going to read that name into the array. And we're initializing our route array by putting a -1. So the first time through the loop, when route is 0, route sub 0 equals -1. Next time through the loop, route sub 1 equals -1. Next time through the loop, route sub 2 equals -1. And that will fill up these two arrays then with the strings of the names of the hotels and with -1 for all of these. Questions? Just getting us back up to what we did last Thursday. Right, and at the very end then, we loaded the distances. So we've got a nested loop here. Show me just 0 through 5, where you are on the feeling of a nested loop. I'm comfortable, 5, I'm really uncomfortable, 0. Okay, so nested loop, I'm seeing mostly 3s and above. So the first time we hit this, y gets set to 0. First time we hit this, x gets set to what? X gets set to 1, because whatever, y is 0, so x is going to be 1. And so we're going to be writing into our distance array at 0, 1. That's the location that we're writing to first, 0, 1 in the array. And we are reading that number right there. So row number y plus 2, so 0 plus 2, row number 2. Column number x plus 2, x is 1, so column number 3. And that's the number that we're reading. Then we're going to put that into our array. And then we're going to put that same value, after we've just written it into that location, we're going to read it from that location, and we're going to put it into the mirror image of the array. So that's what's going to fill in the kind of the bottom half of the triangle as we read across. So now we hit this next, it takes us up. We haven't touched y, y is still 0, but now this x is going to take us 1 larger. In fact, it's syntactically valid to put the control variable here, although it's not necessary. So I can say, just to kind of help me keep track of these loops, this is saying, give me the next x. And this is the end of the x, the loop that's controlled by x. So y is going to stay at 0. X now is going to go to 2. And so we're going to write to the 0, 2 position. We're going to write that number. And we're reading it from, x has gone up. We're reading it from that location there. And then when we flip to the indices, we will write it, that same number, to this location. And that will then fill up. We'll go all the way across. As we're looping across this loop, we'll go all the way across that first row of data. And then y goes up by 1. And then we go through this loop again. And so we'll read this one first time through the loop. Y goes up by 1. Our loop goes through here. Y goes up by 1. Our loop goes through here. And that gets us then these 3 arrays now put into memory, looking just the way they look here. Questions? Yes. Yes. Yeah. So right here. So it used to be in the early days of BASIC, you had to put the control variable here to say, this is the, it's time to get the next value for x. And that's what this would do. Then someone said, you know what? You don't really have to put the x here. We know just because it's the ending of the loop here, you don't really have to put that x in place. And so when they made the VBA language in 1995, they said putting the control variable here is optional. Whereas in prior versions of BASIC, it was just a required part of the syntax. I don't ever put that in place for a loop that's just not nested. But as soon as they get nested, I think it's helpful to say, this is the end of the loop that is controlled by the variable x. And so it's optional syntax. It's around because that's the way the BASIC language was defined before they made VBA. So they said, yeah, we can go ahead and go with that syntax, even though it's not necessary. Other questions? Yes.
Why do you have to fill in the other side of the array? Like, why can't you just leave it blank?
So the question is, why do you have to go through all the work to fill in this whole part down here? Why not just leave it blank? And the answer is, when we allocate the array, it's going to use up all that memory. So I can't make a triangle-shaped array. I can make any rectangle-shaped array I want. I can make a cube array. I could make a 4-dimensional array, which is really hard to visualize, but I could do multiple dimensions. That's okay. But all of the dimensions will be filled. I'm using all those variables. So the reason that I want to fill these in, so number one, it doesn't cost me anything to do it because the memory's already allocated. But now, because I've got all the numbers, I've got the whole array filled, now I can say, all right, I'm interested in knowing what are the distances from the property in Las Vegas. All I have to think about is this row. Because this row now has the distance between Las Vegas and everything else. If I didn't have this filled in, what I'd have to do is I'd have to look down through this until the indices got to be the same, and then switch and go across like this to read those values. Is that doable? That's totally doable. But it's going to be more complex to decide, do I do X first or Y first, depending on which one's bigger. And so since we're already using the memory, we're just simplifying the problem by fully specifying it. Other questions? Okay, well, we've got our, I'm going to go ahead and stop my code here. We've got our subprocedure here initialized that's loading up the arrays, and that's done. So I think our next one is we'll need a subprocedure called calc route. And calc route, so calc route's the one that we're going to call. Say, calculate the route that we're going to take. So I'm going to start off by saying step one is initialize our arrays. So when we say calc route, step one, get the arrays filled up with all their data. And now I'm ready to start building the route. Now, in this case, I'm not going to ask my code to figure out where to start. I'm going to give it a starting place. So we're going to start in Salt Lake City. So here's the visual representation of my arrays. How am I going to say start in Salt Lake City? What do I have to do to say start in Salt Lake City? Go ahead. So route sub 0 equals whatever hotel Salt Lake is, and which hotel number is Salt Lake? Happens to be 1. I probably should restructure the data because the 1 here doesn't mean the first step. It's the 0 that means the first step here. But I'm saying start at this hotel, and the index for that one is 1. And so my first step needs to be to put a 1 right there in that array. And so I'll do that just by saying route sub 0 equals 1. This says start at Salt Lake City, Sheridan. Okay. So we are manually telling it start in Salt Lake. And now we got to tell it, figure out the next place to go. So let me just do this. Ultimately, we're going to need a loop in here. But usually when I'm first starting to figure out an algorithm, rather than trying to think through the mechanics of the loop, what I'll do instead is I'll say, well, let me just write the statement out maybe 3 times. And then I'll kind of be able to see the pattern that loop needs to be able to generate. And so I'm not going to think about the loop yet. I'm just going to say, let's go ahead and calculate our next one. So I'm going to say route sub 1 equals, and now here's where I'm going to have to build the algorithm to figure out what is the next location to go to. And so I think what I'm going to do here is I'm just going to make a separate function. So rather than trying to embed that code right in here, I'm just going to call a function that says, hey, give me the next location. And I'm going to call that next hotel. Now, I have a couple of options. I can either tell it the hotel that I'm currently at. I can say, find me the next hotel from Salt Lake. And how would I tell it? How would I pass Salt Lake? What would I do to tell it, hey, find the next hotel from Salt Lake? Go ahead.
I think you call that row of the array, so row 1 in this case, and then you go and get
Yeah, that's exactly what I have to do. I have to go look at row number 1, but I have a couple of options about how I tell it number 1. So let me go ahead and kind of get this function set up then. So function next hotel. So one way would be to say, I'm expecting when I call this function, you got to tell me what hotel you want to start at. And so I could come here and say current hotel, or maybe I'll just call it, I'll call it current hotel. If I can get on the keyboard lined up. Current hotel, oh man. If you guys hadn't seen me type before I had COVID, I could blame that on COVID, but you saw me for a couple of weeks before. So current hotel as, what data type should that be? Yeah, just whatever data type I'm using, it's just a number. Okay, so now that means I would have to say here, when I'm calling next hotel, I want this function to tell me what the next hotel should go to. And we're telling it start at 1. So this 1 is going to say, all right, that's going to become the value for current hotel. And that's how I'll know which row to be able to look at in the array. So now what we're saying is that the only part of my distance array that's relevant is this row right here, because this shows me the distance between Salt Lake City and every other property. I can learn nothing by looking at this cell because that's the distance between Las Vegas and the Phoenician, wherever the Phoenician is. And so, looking at this one here doesn't tell me anything. The only part of this array that I'm concerned about is the one on row number 1. And so I could do it that way. What's another way that I could figure out what's the row I'm supposed to look at? I could do it without telling the function at all. How else could I tell what hotel I'm currently looking at? Or looking to find the next step from? Well, because my route array is a module level variable, then I could say, listen, I know the distance. I mean, I know where to start from, because all I have to do is come down here, start at the bottom of this array, and count up until I find a number besides -1. Right? My next hotel function can look at the route array, and it could find that 1 is the relevant number by starting here and just going up, 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 up until it finds something besides -1. It would find it here, would go 1. Oh, that must be where we currently are. Which one do you like better? Should we tell it where to look from? Or should we make calc route figure out where to look? I don't care which way we do it. Either way works fine. Go ahead. Well, when I said I don't care, I didn't really mean I don't care, because I've already done one way. It's already done here. The other way, of course, we have to make a loop. We have to loop and kind of count through and go find the one. We could do that. But yeah, I do care. I like this way better because it's already done. I'm already telling it. I mean, the code's written. Yeah. There's a question up here. Yeah, sorry, I can't see who it is. Yeah, go ahead.
Would you write 1 or would you reference routes?
Oh, excellent. Okay, so what you're saying here is you just put a 1 into route sub 0. So maybe what we should be doing here is, instead of having this hard coded as 1, we should put here whatever route we just put in there, right? Read that 1 off of my route array rather than having it hard coded. Yeah, that's exactly what I want to do. I'm going to leave it less abstract for now. And then when we get it to make the loop, we'll do that very thing. Yeah. Or we wouldn't even have to worry about it if we just made next hotel figure it out. I think we'll just go ahead and go this way. Okay, so now what I'd like to do is, I think I'd like to just kind of get the mechanics involved here. I'd like to just make sure that I can manipulate my loop without trying to actually think about how am I going to figure out which one's the right one to look at. Let me just see if I can print off the values I have to consider. So let me dim x as an integer here. And by the way, anytime I declare a single value numeric variable, there are some faculty in this college who would say never ever declare a variable that's just a single letter because it's not meaningful. And that's probably a good idea. But for me, I know if I ever declare a variable with a single letter, I'm just going to use it to control a numeric loop. And we all know that the less I type, the better it is for everyone. So yeah, I don't know. I could call that hotel counter or something. Okay, so now I'm just going to say for x equals 0 to, let me just look at my route. And I actually want to know the upper boundary of the route. Now, you remember that we declared a variable down here called hotel count. Now, why can't and I use hotel count to actually set the upper boundary of that. Why can't I just refer to, instead of, the upper boundary, instead of asking for what the upper boundary of the route array is, why can't I just say hotel count -1 here? It's because the scope. I declared that here, a hotel count is a local variable. It's only available inside of this subprocedure. Now, I could just make this a module level variable, put it up here. And then I could just say hotel count -1 anytime I wanted to refer to the upper boundary of any array that I want. That would be fine too. But I don't mind getting a little practice with this function called ubound that reads the upper boundary off of an array. And since that array is a module level variable, I can ask how big it is just fine. Debug.print. And let me go ahead and, I'm looking at the distances is what I want. So let me go ahead and print on my current hotel. So that'll be 1 when I call this. I'll print x, which will be the hotel number that I'm referring to, and then I'll print the distance using those two indices. And so this should print off 36 distances. So it's going to always print, when I call it here, since I'm calling it with a 1, 1 is going to come into my current hotel. So it'll print 1 and then 0. So the distance between hotel number 1 and hotel number 0. And then it should read the distance off the array and show me that number. Then we're going to get through x will become the next number higher. So I'll then print the current hotel 1, distance between the current hotel 1 and hotel 1. It'll look in the distance array, and what will that one print? It'll print 0 because it's, that's the distance between these two. So the first time through, we should be looking only at this part of the array. The first time through, we should print 691, then 0, then 653, and so forth. Yes, hold on one second. Just put a data type on this, and then I'm ready. Go ahead. Question?
Yeah. So just to visualize it on our array sheet, when you're doing ubound, that's like the top one of route, that's 0 and 1.
That's right. It's actually looking at the highest. So the question is, what is ubound doing? And ubound is saying, listen, I want to find out what is the upper boundary of this array. So it finds out what the biggest index number for that array.
Okay. And then on a two-dimensional array, where would that go?
Oh boy, two-dimensional array, upper boundary, because there's two upper boundaries. There's an upper boundary for this dimension and an upper boundary for this dimension. Yeah. So yeah, you can ask that. Let me go ahead and put a breakpoint in here after we've got our arrays initialized, and then we can take a look at that. Oops, get rid of that one and get rid of this one. Okay, so now we've run our whole init, so our arrays should be loaded and initialized. So I can ask for the upper boundary of hotel, hotel. That should be exactly the same as the upper boundary of route. Now, but when I say distance, it doesn't know which dimension I mean. And so I could ask for the first dimension, and it tells me 35, Or I can ask, I'm not sure if it's the 0 or the 2 dimension. I think it's the 2 dimension. Yeah, the second dimension is 35. So even though the dimensions themselves start counting at 0, the first dimension is dimension number 1, and the second dimension is dimension number 2. And so the second argument says if I've got a multi-dimensional array, which dimension am I asking for the upper boundary on? Because these are all 35 for our problem. They'll all be the same. I'm probably just going to use a simpler one here. Even though I'm going to be looking at my distance, it might make sense to look at the upper boundary of one of the dimensions of distance, but I know that they're all the same. So I'm just picking route because it's simpler to write. Other questions? All right, I'm going to go ahead and run this through. Maybe I'll step through it, F8. So we set up the route. We're calling this one. Make sure that we've got it clean. Okay, so first time through, this is going to be 0, or current hotel will be 1 because we passed the 1 down. X is going to be 0, so it should print 1, 0, and then 690. Oops. Let me try that again. What did it say? Objects property or method. Oh, it's because it's not distance, it's called dist. Yeah, I've stopped there, so I'll step F8. Next time through the loop, X has gone up. So now from hotel 1 to hotel 1, 0 miles. From hotel 1 to hotel 2, 653. What's our next one supposed to be? 662. And so we'll just kind of lay through that and we'll see us looking across that one row of the array and getting all of those distances. Okay, so now I've got the mechanics in place of being able to address each one of these numbers. Now it's just time for me to figure out which one is the shortest. Now, by the way, which number is going to be the smallest? Yeah, 0 is going to be the smallest because we're always there. But by the time we get here, we are at Salt Lake City, which means we have been to Salt Lake City. So we don't really need to think special about, are we at the hotel that we're looking for? We just need to say, we only want to consider those hotels that we haven't been to. So when I'm printing off this, instead of just printing this, I want to say, well, before we print it, before this is a number to actually consider, I want to know if it's the one that we've been to or not. And so I'm going to say if, and I'll write a new function, been there. And I will send it the one I'm currently considering. So X is the one that's going to go across the whole range. In fact, I probably want to say if I haven't been there. If not been there, then we'll print. So I'm now going to set up a function called been there that takes a hotel index and just going to return true or false based on what? Based on if the number I pass appears as data in the route array. Whew, making another function. We're function happy today. Woohoo. Been there.
You did that before the end function.
Oh yeah, that's a problem. It has to come in here between. In some languages, you could put a function inside another function. It would only be accessible from inside that function. You can't do that in VBA. All functions have to be at the main level. Okay, and this is going to be, what type should we have this function return? Yeah, Boolean. So this is going to return Boolean, which just tells us it's going to be true or false. All right, so here we just need to look through that route array. In fact, I'm going to copy the whole structure I've got here because I'm going to have to declare a variable, loop through, and so forth. So we're declaring a variable. That's going to go across my whole route array. Now here's where I want to check to see, if I've been there. So I'm going to say if the hotel, whoops, let me bring this in as an integer as well. If the hotel that I'm currently being asked to consider, sending down number 3, I want to know, have I been there before? So if hotel number 3 is equal to route sub X, then we've been there. So if we think about this, I'm looking, let's say I'm looking for hotel number 3. My loop's going to start at 0, and it's going to look at route sub 0, and it's going to say, is that a 3? If it is, we've been there. It's not, so we haven't. It's going to go route sub 1. Is that a 3? No. Is that a 3? Is that a 3? It's going to go through all of these. It's never going to find a 3. And so at the very end, this should return what? If it doesn't ever get into this part of the loop, what does it mean? We haven't been there, so it should return false. So been there is false, haven't been there. What data type will this be by default? It'll be false. It's Boolean, so it'll be false. It's actually implemented as a 0, but it's false. So if we don't ever tell it that it's going to be true, it will return false. So I don't need to tell it to return false. If you really wanted to, you could say, all right, if we ever make it to the bottom of this, some people like to see that expressly, set its return value. But if we do find it, let's say we've got a 3 right here. If we do find it, route sub X does equal 3, then, well, been there is going to equal true. Is there any reason for us to keep looking? Well, what if it finds a 3 later on? Maybe 3 is in there twice for some unknown reason. Maybe 3 is in there twice. What are we going to send back? Really true? It's extra true? It's twice as true? No, there's no reason to keep looking. And so what am I going to put here? Exit function. UNC. So now been there will look at our route array and just look at whatever number we passed in, whatever hotel number we passed in, it'll tell us, is that already in the array? If it is, we've been there. So now we are only going to print this number. We're only considering this number if we haven't been there. So if this returns true, we've been there, then we want this whole expression to just be the opposite. So if this returns false, haven't been there, then this whole thing will be true and we'll print this off. Now, the only one that we've got so far is a hotel number 1. So when I run this code, it should print off everything except the distance between hotel 1 and hotel 1. So we're comparing hotel 1 to 0, 691 miles. We're comparing hotel number 1 to hotel number 2, 653 miles. So that the been there function now has correctly reported, you've already been to Salt Lake City. That's not one that we're going to be considering. So now when I get to this line right here, if I'm actually on this line, then X is one of the hotels I should be considering. So now it's just a matter of figuring out which is the smallest of all the numbers that are going to now get printed, which one's the smallest? Any thoughts on how we should tackle this? Because this is the homework that's due tonight, right? It's kind of look at a set of numbers and figure out which one is the smallest. Yep.
Create a variable that sets at least the first number as the thing, and compare everything to that and see if the other number is smaller.
Okay, so what you're saying is, let's get some number that says, here's some number to compare against. And now we want to find any one that's smaller than that. We want to find the smallest number, the smallest one we want to find the smallest one. Okay, in fact, I'm going to need 2 variables because ultimately what I have to return is not the smallest number that I found, but what? Yeah, the index, where that smallest, the hotel that has the shortest distance. So let me dim short distance as an integer. And let me dim short, or I'll call it close hotel, also as an integer. Now, you're right, we got to give it some value to start with. So let me give my short distance an initial value. And I'm going to give it to 24,000 miles. Why 24,000 miles? $24,000 miles is the circumference of the Earth. And so if I'm saying, you know what, The distance between this hotel and another one is something more than 24,000 miles. You're going the wrong way, like going around the world to get there. So that's no good. And so I just really want to give it some number that when I make the first comparison, that first comparison is going to be the one that becomes the shortest one. So I want to say it, hey, whichever number I pick up first, I want that one to be my contender, the smallest one I've really seen. Other folks might say a better number here is 32,767, which is the upper boundary that could fit in there. I don't care, as long as it's a bigger number than I'm going to ever see in my data. Okay, so now if I haven't been there, so any number in here is a possible contender. So I'm going to say if the distance that I'm printing out is less than my short distance, then, in fact, let me go ahead and print the numbers out. And I'm going to say if that number that I just printed off is smaller than my short distance, this becomes the new smallest distance that I've seen. I got to keep track of two things. Number one, I've got to keep track of the fact that that is my new shortest distance that I've seen. And I have to keep track of where I saw that. So close hotel. So each time I find another value that's shorter than the one I've seen before, then shorter than the smallest one I've seen before, then I'm going to say, okay, that's my new contender. And I got to remember that's the hotel number that I saw it at. Because when I'm done with this loop, close hotel is what I have to return. Ooh, this is not especially simple code. It's not terribly complex, but it's not really simple either. So let's go ahead and run it, and we'll step through it. We clear this out and run this. Now I'm stepping into my code. So all my arrays now are initialized. They've got all the values in them. I'm setting my short distance to some pretty big number. I'm now looping through the array. If I haven't been there, I'm just going to step over this. So you shift F8. I'm comparing now between hotel. Just go ahead and come up here and say, I want to see what my X is and what my current hotel is. So I'm comparing the distance between 0 and 1. So I'm going to be asking myself, is that, oh, we're printing that off. Maybe I won't print that off right away. So now I'm going to say if the distance to that hotel is less than my current short distance. Okay, so is the distance that I'm currently seeing, the distance between Salt Lake and that one in Anaheim, is that distance smaller than my current short distance? It is, and so we should come into this if statement, and now we're going to say our new short distance is the one that we just saw. So we'll replace short distance, which was 32,000, with 691, and then we're going to remember that close hotel, the smallest one we've seen was hotel number 0. We'll come back through here again. Oops, we're going to bin there. Anyway, we skipped that one over because we haven't been there. So we're not going to get for hotel number 1. So now we're looking at an X of 2. Have we been there? Apparently we have not been there. Here's now what we're looking at. Current shortest distance is 691. We've now found another one is 653. Is it smaller? Yeah, this is our new next contender. So we should step into here. Remember that one, remember where we saw it. Now we're looking at one that's 622. Our current contender is 653. Is this a shorter distance? Is this one closer? No. So we should skip over the if statement. Looking for the next one. 659 compared to 653, not smaller. Should skip over that one. What's our next one? 650 compared to 653. That's my new shortest one I've seen. So I should come into this one. Remember that one? $661 versus 650 shouldn't go into this one. We'll just skip over it. Now, this is another one. 425 is smaller. And so we should be able to come into that one, remember that one. And that's the smallest one we're going to find. If we look at here, there's the 425 that we just saw. And if we look across all the rest of these, we'll see there's not another shorter one. So I'm going to run the rest of the way this out. And now our close hotel is still number 7. We're going to set the return value for this. And we've just now put whatever this evaluated to, 7, into route sub 1. So if I come here and look at route sub 1, what should I expect to see? Yeah, that should be 7. And that's what it's giving me, 7. Whew. How are we feeling with the next hotel algorithm? Show me 0 to 5. 5, 5, 5, 5, 5, 3, 5, 3, 3s and 5s. Okay, question.
Remember, isn't this just more manually running a manual function, right? Can't you just use like a worksheets function, like the min of?
Yeah. So the question is, why don't you use the min function? We go with a worksheets function called min. Why can't we just use that? And the answer is, what we have to look at is we could do that. Yeah, we could do that here, but it's not just the 0. It is the first time through here. The only one I have to not consider is the 0. So we can't just use min because it's going to kick back 0. But it gets even worse because our next one is to look down here at number 7. And yeah, we have to skip number 7, but what else do we have to skip? We've got to skip this one, 425, because it turns out that's the closest one to Las Vegas is Salt Lake City. So if we don't skip this one, it's going to send us right back to Salt Lake. We don't want that. So yeah, we can't just say, use the min function to find the smallest value, because as the further down here we get, the less of these numbers we're actually considering, which is why we're doing it in a little more manual way. Right? So we've got the logic in here that says, consider it if we haven't been there, and if it's smaller than the smallest one we've seen so far, then that's our new next contender. Okay, so yeah, go ahead.
So I was following along with, I had it, I was running it on like debug, and I was holding down F8, it was just going through. And so I got to 425, that number with the same time as you did. But my code, it looks like it's going to keep going through to check past 425.
Oh, yes. Okay, so the question is, hey, if we keep stepping through this, let me just I'm going to put a breakpoint here. And maybe we'll go ahead and print this just before we get to this spot right here. Okay. Let me go ahead and run this out. Clear this. Calc route F5. Okay, so we're finding the 691. I'm just going to run these one at a time. F8, shift F8. No, F5, because I got to break point F5. Okay, so we're finding between 3 and 1. We've got that. Oh, I got to quit clicking up there. Eventually, we're going to get to 7. Okay, so there's the 425. That's the smallest one. Now you're saying, hey, mine kept going. Yeah, it's still going. I didn't actually step through it because I knew we weren't going to find a smaller number. But this is going to keep going all the way through until it has gone through that whole row. And then, but you'll see that we don't ever actually hit this breakpoint in here. So I'm just running, and it's not hitting that one because it's going to go all the way through 35. And it never came back into this if again. Okay. So now after we calculate that one, I'm looking for the next one. And that's going to start at number 7. Ultimately, we're going to make a loop to do this for us. But let me just go ahead and have a stop here. So let me F5. I'll F5 to run this one, and then I'll shift F8 just to kind of run through these. So I should be able to look now at route number 2. So it wasn't property 19 wasn't our next one, it was property 12. So if we think about where we are right here, we've just put a 7 there, we've just put a 12 here. Who's 12? Some place called Fairplex. So let me write one more in here. So route number 3 is going to come from hotel number 12. And let's see what route 3 is.
It's in the LA area. Number 12 is.
That doesn't surprise me to hear that it's in the LA area. You just looked it up, or you looked it up, did you Google it, or did you look it up on the sheet? Because I think the address is actually on one of our other sheets. Route number 3 is 19. So 19 is the 4th step, not the 3rd step in the route. Okay, so our next one, I think we're done with this here, but this is what we've got to produce. We've got to give ourselves a loop that is going to give us this sequence. This sequence is easy. We just got to go to 1 to the upper boundary, right? So 1, 2, 3, 4, 5. This one's harder. 1, 7, 12, 19. But a student already pointed out what we have to do here, because we're really looking at so to get the 1, we just put that 1 into route sub 0. So that 1 should be route sub 0. Then we're putting the 7 into route sub 1. This one should be route sub 1. So we're always looking back one spot in the route relative to the one that we're getting ready to fill. So when we're putting route number 1, we're starting at route 0. When we're putting the second slot or the number 2 in the route, we're just looking one back from there. Now we've got 2 vectors of numbers that we should be able to do with a loop pretty easily. So let's just go ahead and do it. I'll stop my code. Mx as an integer. For x equals 1 to the upper boundary of my route. Next, I'll just copy one of these lines in. So we're going to look at route sub x, and we're going to go to route sub what? X minus 1. And we'll just make another loop that goes from 0 to the upper boundary. And here I'm going to print off my route. So that should print off 1, 7, 12, 19, and then the whole rest. Whew. See, I'm going to get rid of this stop up here. And I'm going to run calc route. And I had some of the debugs. It's making that look a little bit confusing. So let me get rid of that debug statement. And there's the route. Start in Salt Lake, go to Las Vegas, go to the Fairplex, go to Anaheim, and probably a couple more down in the Los Angeles area. But we don't have to just, I'll go ahead and print the route, but let's also print hotel. So the first time through, I want to print hotel sub 1, which will give me Salt Lake City. Then I want to print hotel 7, which will give me Las Vegas. Then hotel 12, which will give me the Fairplex. So what do I put in here? Yeah, just route sub X. And so that should show me the hotel number, and then it should show me the actual name of the hotel. Let's see how we feel about the route. So here's what it calculates. Start in Salt Lake City, go to Las Vegas. So far, so good. Fairplex is down in Los Angeles, Anaheim, Los Angeles area, Anaheim again. Anyone know where Cerritos is? Los Angeles area. We're doing pretty good. Long Beach, Los Angeles, Beverly Hills, Los Angeles, looking pretty good. Monarch Beach, still LA, I think. La Jolla, where's La Jolla? Yeah, so now we're going, that's pretty good. We came down to Las Vegas, now we're going to LA, and now we've dropped down to San Diego. San Diego, that's doing pretty good. That's good. Now Palm Springs, a little more inland, a little more up. I'm not sure this is the best way to go to Palm Springs. You probably should have gone to Palm Springs, maybe on the way to Los Angeles. I don't know Southern California that well. But okay, Bakersfield, Central California, San Jose, Northern California. It's not too bad. Silicon Valley, San Francisco. I'm not sure where. I think this is a miss. I think this is actually bad in the data. We're not really going to Montreal. Anyway, the distance, I think we'll go look at the distance. That would be somewhere in the Los Angeles or in the Bay Area. San Francisco, San Rafael. So we're up there. Sacramento, Seattle. We went right up the coast. Seattle. I don't know where Santa's hotel is. I thought that was the North Pole, but okay. Oh, Scottsdale. What's Scottsdale? Phoenix. So we go, start in Salt Lake City, we go to Las Vegas, LA, San Diego, Central California, Northern California, Washington State, and then Arizona. What would have been better? Las Vegas, Arizona, San Diego, up the coast. So remember when I said that the next nearest city algorithm is not going to give us the shortest route? No, but it's going to give us a reasonable route. Is it the best route? Not by a long shot. Could you have done better with a map and a pencil? Yeah, but you could not have done better with a map and a pencil 500,000 times a day, right? So that's the idea, is make an algorithm that could do it. Maybe not the best, but at least one that we could actually get out there and drive. The next nearest city algorithm is like the simplest, somewhat reasonable solution. And of course, mathematicians have spent careers trying to figure out better approaches. Our goal was really to get familiar working with arrays. And so it was a pretty reasonable thing to do, even if it's somewhat dissatisfying to see the ultimate route that it produces. Questions? In the back.
Should I just see the code for the next hotel function?
I think I just closed the wrong thing. Yes, you can see the next hotel function. Oh, uncharacteristically, I'm about to let you out 5 minutes early. Well, 4 minutes early, but I'm not opposed to that. Thank you for coming. Class dismissed. Oh, we got somebody on chat who's chatted something. Who did chat?